As we now have a typed client, we can move some implementation details to it. This is a Movies client, intended to use for integrating with our Movies API. From that, we can offload the implementation of, for example, getting a list of movies to that class. Of course, methods for creating, updating and deleting movies can also belong in this class. But we'll implement getting a list of movies as an example. So we're looking at our Movies client. Here we want to add one method, getMovies. It returns a task of IEnumerable movie. That makes it an awaitable method with an IEnumerable of movie as result. Let's import the necessary namespaces. Task is from system.threading.tasks. Movie is from movies.client.models. And the cancellation token is from system.threading. In this method, we create a new GET request to API/movies. We pass through an accept header with value application JSON, and we pass through gzip as value for accept encoding. Then we send the request using the client property from our Movies client class. The rest of the code follows the best practices we've implemented up until now. Read and deserialize from JSON is defined in Marvin.stream extensions. Let's clean up the spaces a bit, and there we go. Once the response has been read, we return the list of movies. Like this, we are containing the methods related to interacting with the Movies API inside of the client, which makes it easier to reuse this Movies client across different parts of your code. Now, if you're going this route, I'd suggest not exposing the client property anymore. It's not needed, as consuming classes can use one of the methods defined on Movies client, like getMovies to get a list of movies. So let's refactor this a bit. Instead of exposing it as a public property, we're gonna make it a private field. There we go. Let's save this and let's open our service again. First of all, let's comment out our old getMovies with typed HTTP client from factory method. This one won't work anymore because it uses the now unavailable client property of our Movies client. And let's add a new method, getMovies via Movies client. It accepts a cancellation token, and as all the functionality to actually interact with the API is now moved to the typed Movies client, all that's required here is a call into getMovies on Movies client. Let's put a breakpoint here, and let's make sure we call this method when we run the application. That's the old one that's commented out, so let's comment this one out as well. And there we go. Let's give this a try. We hit our first breakpoint. We hit our breakpoint. And here's our list of movies. To round things up, named and typed instances can be combined. You can name a specific typed instance if you want to when registering it, just as we previously did. But if you do that, I would suggest to keep the configuration out of the typed client, as you're working with a named client, and that can now have its own specific client configuration. And with that, we learned a lot about using HTTP Client Factory. Let's have a look at the module summary. When we dispose of HTTP client, the underlying HTTP client handler is disposed of as well. This results in connections having to be closed and reopened for additional requests, which can eventually lead to no more sockets being available to open these new connections. That results in a bad experience for the user of your application. On the other hand, if we keep on reusing the instance, the connection is reused as well. And that means that DNS changes aren't honored, which can result in our application trying to call an API through a URI that no longer matches the correct server. To solve these issues, Microsoft introduced the HTTP Client Factory. It's responsible for creating and managing instances of HTTP client and related handlers, and it mitigates both issues. Currently, it's best practice to use this factory instead of creating instances ourselves. As we've seen in the demos, it supports direct instantiation, named instances, and typed instances. There's no best option here. It really depends on your requirements and/or architecture. In the previous module, we encountered the task cancelled exception and we handled it. There's more to handling faults and errors than just that. Let's check that out in the next module. Correctly dealing with errors and faults when integrating with an API is essential and can make up the difference between a stable and failing client application. In this module you'll learn how. I'm Kevin and I'll guide you through it. We'll start by learning about status codes and why that ensure success status code statement we've used up until now isn't necessarily a good idea. We will learn how to inspect these status codes in code and act on them. Afterwards, we'll learn how we can read out the response body in case the API returns useful information in it. And lastly, we'll learn how we can integrate with APIs that somewhat bend the rules of good API design. Let's dive in. Up until now, we've used response.ensure success status code throughout our demos. When this code is encountered, anything except something in the range of the 200 status codes will throw an HTTP request exception. For most cases, that's not what we want to do, because different status codes require us to react differently. Let's have a look at what types of status codes we have. There's 5 levels of status codes. Level 100 status codes are informational and weren't part of the HTTP 1 standard. These are rarely used by APIs. The level 200 status codes mean the request went well. The most common ones are 200 for a successful GET request, 201 for the successful request that resulted in the creation of a new resource, and 204 for a successful request that shouldn't return anything, like a successful delete statement. Level 300 status codes are used for redirection. For example, to tell a search engine a page has permanently moved. Most APIs don't have a need for these, but if they do, HTTP client can automatically deal with them. Then there's the status codes that tell the consuming application it did something wrong. Level 400, client mistakes. The most common ones are 400 bad requests. The request you, as a consumer of the API, sent to the server is wrong. For example, the JSON the consumer provided can't be parsed. 401 unauthorized means that no or invalid authentication details were provided. 403 forbidden means that the authentication succeeded, but the authenticated user does not have access to the requested resource. 404 not found means that the requested resource doesn't exist. And 422 stands for unprocessable entity. It's part of the WebDAV HTTP extension standard, and it's typically used for semantic mistakes. And semantic mistakes, that's what we get when working with validation. If a validation rule fails, 422 is what's returned. Problems in the 400 range are categorized as errors. The consumer of the API passes invalid data to the API, and the API correctly rejects the request. Examples include invalid credentials, incorrect parameters, invalid content, and so on. Lastly, there's level 500, server mistakes. Often only the 500 internal server error is supported by APIs. This means the server made a mistake and the client can't do anything about it other than trying again later. Problems in this range are defined as faults. The API fails to correctly return a response to a valid request by a consumer. In other words, the API made a mistake. So if an error happens like a 404 not found, we don't necessarily want our application to throw an exception and crash. We may want to show our user that he or she made an input mistake when typing in the movie ID, for example. In other words, we want to inspect the status code. Time for a demo. We'll start by learning how to inspect status codes in this demo. We'll do that in the Dealing with Errors and Faults service. Let me paste in the code we're going to start from. There's nothing out of the ordinary in this code. Via constructor injection, we have access to the HTTP client factory. We also define a private cancellation token source, so we can get a cancellation token from that to pass through to the HTTP client send async method. There's one method defined here, get movie and deal with invalid responses. And when the run action executes, that action is called. If you look at this code, we see that we create a new movies client via the HTTP client factory. That client is then used to send a GET request to get one specific movie. Just as before, we set completion mode to response headers read, we pass through a cancellation token, and we read out the content as a stream. The thing is that the URI we pass in the request to get one movie isn't valid. It should result in a 404 not found. We are, however, still calling ensure success status code. That'll have to change, but let's see what happens if we still do that. Let's make sure this service is used when we run the application. For that, we open the program class, we scroll down a bit. Instead of registering the service from the previous module, we register the service related to this module, the dealing with errors and faults service. Alright, let's build and run. And there we go. Our application just crashed with an exception. That's not what we want. In case of a 404 not found, you might want the application to show this to your user or show a nice error page. But in any case, you don't just want the application to crash out with an exception. Let's open our code again. Instead of calling response.ensure success status code, we can check if the status code indicates success or not through the isSuccess status code property. This boolean will be true if the status code is in the 200 range. If the response doesn't indicate success, we still need to know the actual status code. We can get to that via response.statuscode. If the status code equals to a not found, we want to show this to the user. For the demo, we'll write out a message to the console. It's here that we can also try and handle other types of errors or faults. So this is how to deal with additional status codes as well. For example, when we get back an unauthorized, we want to trigger a login flow. In a real-life situation, you would probably want to trigger your authentication middleware to handle this. For the demo, we'll keep it at these two status codes. But if you're handling more, a switch structure is a better option. Now, if we're only handling two status codes, that means that other problems might happen as well. We're not specifically handling those, so in those circumstances, we still want to throw an exception. And we already know how to do that. By calling response.ensure success status code. Alright, let's give this a try. And there we go, much better. Our request resulted in a 404 not found response, so we see a message, the requested movie cannot be found, written out to our console window. Let's continue with learning when it can be useful to inspect the response body.